All right. Hello, guys. This is going to be the 2024 Number Sense UIL State Guide. I'm going to be going over the entire test and explaining how to solve each problem. Let's begin. So, number one, 5 times 15 plus 2024. Well, 5 times 15 is clearly 75. Add that to 2024 and you get 2099. Number two, 24 divided by 2 over 3 minus 15.5. That's the equivalent of 24 times the inverse, so times 3 over 2. 24 over 2 is 12, times 3 is 36. And subtract that from 15.5 to get 20.5. Excuse me. 3. 7 ninths divided by 2 over thirds is 2 over 3 is equal to 7 ninths times 3 over 2. This 3 and 9 are going to cancel. The 3 here and 9 here to make divide by 3. So 7 over 2 divided by 3 is 7 over 6. Number 4, 7/8 as a decimal. Well, this is just a decimal you should know. 1/8 is 0.125. Subtract that from 1 and you get 0.875. Number 5, 5 cubed, which is 125, minus 15 squared, which you should know to be 225, plus 24. It's just about knowing your cubes and squares, which these are pretty easy ones to memorize. And you add them all together. Negative 100 plus 24 is equal to negative 100 minus 24. Then you get negative 20 or negative 76. 0.8333. This is another one of just recognize the fraction is 5 over 6 and move on. Number 7, 666 times 2 over 37. 37 times 3 is equal to 111. That's multiplied by 6 to get 666 over 37 is equal to 6 times 3 is equal to 18. Then you multiply by this 2 on the numerator, and you get a value of 36. So yeah, this number 6 here multiplied by a constant 3 multiplied by this 2 up here. Number 8 is literally just the first problem, but with Roman numerals. M is 1,000, X is 10, V is 5, I is 1. And if you do that, you get the same answer of 2,099, which is larger, 7/12 or 0.58. Well, 7/12 you should know to be point to be 6/12 or 0.5 plus 1/12, which is 0.08333333, which is another fraction you should know. So you're asking, is 0.58333 greater than 0.58, which it is. So 7/12 is the larger number. 4,200 times 51. So you can approximate it. It's a little more than 4,200 times 50, which is going to be equivalent to this number divided by 2 times 100, as seen here. As multiply by 2, divide by 2, and then increase it a little to account for that. So that's why this 5 is here, and that'll easily be in range. 11. If hankies cost $1.50 and a dozen costs $15.75, how much is saved by buying a dozen? Well, 1.5 times 12, basically. So 12, 1.5, it's the times 15 rule. 12 plus 12 over 2 is equal to 6. Will get you 18. So your value is 18 or dollars to buy a dozen with individual hankies, and then you subtract 15.75 from that to get 2.25. Number 12, 24 divided by 20 minus 16, plus 12 minus 8 times 4. Well, 24 over 4 is 6, because that's what this is. Then you're adding 12, and then you're subtracting 8 times 4, which is 32. So 6 plus 12 is 18, minus 32 is negative 14. 13, 155 times 14. You'll just need a FOIL like normal for this. So 4 times, if you're watching the state guide, you should know how to do that. 4 times 5 is 20. Carry the 2. 4 times 5 plus 5 times 1 plus 2 gets you 27, and so on and so forth. 14. 54 squared. Well, this is your near 50s trick. So you start with the 2 500. Then you add 4 times 100, because that would be what you get when distributing this. And then you add the 4 squared as 16. So that's just gotten by distributing 50 plus 4 squared. And if you do that, you get 2,916. 15, all this stuff, 1 over 27 minus 1 over 9 minus 1 over 3. Well, we'll need to put them all under the same base. The common base you can see to be 27. So 1 over 27 minus 3 over 27 minus 9 over 27, which is done by multiplying the numerator and denominator by 3 and 9 respectively. So you simply subtract that and you get negative 11 over 27 as your answer. 16, 3 plus 5 plus 7 plus 9, etc. till plus 21. This is an arithmetic series. We need to figure out the number of terms, which is going to be equivalent to the first minus the last divided by the ratio plus 1. So 21 minus 3 is 18. That divided by the common ratio of 2, each number is 2 greater than the previous, gives you 9. And then you add 1, so you have 10 terms. So, excuse me. Once you have that, you have the number of terms. Then you need to multiply it by these two numbers combined and divide by 2. So as a result, 21 plus 3 is 24. So 10 times 24 divided by 2 is equal to 10 times 12 is equal to 120. 17, 25 times 64. Well, 25 is equal to 100 divided by 4, so 64 over 4 times 100 is the equivalent. And you just get 16 times 100, which is 1600. 18, 26.25 times 64. Well, it's the previous 25 times 64 plus an extra 1.25 times 64. 1.25 is equivalent to 5 over 4. So 5 over 4 times 64 is equal to 16 times 5. Just this divided by that times that is equal to 80. So add 80 to your previous 1600, and you'll get number 18 as 1680. 19, 102 and 1/2 times 64. Well, 100 times 64 is obviously 6400. And then you have to add on an extra 2.5 times 64. Well, 2.5 times 64 is equivalent to 64 times 10 over 4. Same process we did when multiplying by the 25. So 64 divided by 4 is 16, times 10 is 160. So add 160 to your 6400 and you'll get your answer. Okay, 2024 times, 24 times square root of 15 plus square root of 5. Okay, well, you got to approximate square root of 15 and square root of 5 here. This is a little less than 4 squared is equal to 16, so 3.8. And then square root of 5 you should have memorized to be 2.236, I believe. And then once you add those together, you see that they're about 6. And then you can multiply that by 2,000 to get 1,200. Okay, 39 times 31. Well, the ones digits add up to 10, and the tens places are both the same, which means you can use a special trick for that. The tens in the ones place is going to be equivalent to the ones multiplied by each other, so 9 times 1 is 9, so 0, 9. And then tens place is equivalent to the number times that number plus 1 is equal to 12. So 12 over 9. 22, 4 and 2/3 divided by 2 and 4/9. This is just about matter of putting it in terms of improper fractions. I guess I forgot to write the description. Uh, excuse me. Sorry. Yeah, I guess I forgot to write the description for that. Essentially, you put this fraction up here and you get 14 over 3. Then you're dividing that by moving this fraction over is 22 over 3. Or 20, sorry. Yeah, dividing by 22 over 9. So you flip that. Now you have 14 over 3 times 9 over 22. So you divide the 14 and 22 by 2 to get 7 over 11 times 9 over 3. So 7 over 11 times 3 is equal to 21 over 11. 40 minus 60% times 80. So 40 minus 0.6 times 80. 6 times 8 is 48. And then you judge You adjust it accordingly because this is a little less than 1 times 60, so 48. 48 minus 48 is equal to negative 8, and that'll be your answer for 23. 24, 0.515151. Well, all numbers are repeating, and there's 2 repeating numbers, which means you're dividing by 99. If there was only one repeating number, if it was 5.511111, you'd be dividing by 90. But now that you're dividing by 99, it's just going to be the number that's repeating, so 51. 51 over 99, which can be simplified to 17 over 33. 25. If f of x is equal to 16x squared minus 40x plus 25, f of 15 is what? Well, if you bring this kind of thing in, you'll see that it's equivalent to 4x minus 5 squared, because, this 4 here, this 4 squared here, this 5 squared here, and this negative 40x makes sense. So 4 times 15 is 60, minus 5 is 55, and then 55 squared, you use your normal both numbers end with 5 trick, or numbers end with 5 in our squared trick. So 5 times 6 is equal to 30. That's your first 2 digits. And then 25 is always your last 2. 26. This is just going to be another FOIL like normal problem. I won't go through it with you. You should know how to do that. 27. Write 5 and 3/5 million, 2024 in digits. Well, 5 million, and then you'd have 3/5 million. So 3/5 of a million is 600,000. 3 over 5 times a million. So 5,600,000, 2,000, as shown here, and then 24. So you just get rid of the commas, and you have your answer. 28, 10 and 5/7 times 10 and 2/7. Well, both of these whole numbers are the same, and both of these fractions add up to 1. So we can use a special trick for that again. Multiply this 10 by that 10 plus 1, get you 110. That'll be your whole number. So because you can imagine that these two 10s are being multiplied by each other, and 110 is being multiplied by the sum of these. So plus 10 times 1. So 10 times 11 gets you 110. That's your whole number. And then now you just multiply the fractions. 5 times 2 is 10, divided by 7 squared is equal to 49. And you have your answer. 29. 515 base 10 is written in what base 5? Well, base 5, we got to figure out how many of 5 factors go into it. So the highest 5 value that would go into this seems to be 5 cubed. So 125, because 605 power to 4, 625 is too much. So 5 power to 3 is 125. Well, that can go into 515 4 times. Multiply it by 4 to get 500. So that'll be your first digit. Now you have 15 left over. 15 does not go into 25 a single time, which would be 5 squared, which corresponds to this digit. But it does go into 5 power to 1 3 times. So 15 is equal to 5 power to 1 times 3. So that's a 3-digit there. And then you have nothing left over, so your 1's digit is going to be a 0. Number 30. Okay, this is a square root approximation. Make your groups. 1 group of 2, 2 groups of 2, 3 groups of 2, and 4 groups to start. So 4 groups, that means there's going to be 4 digits. And then this 550 is pretty close to 23 squared, which is equivalent to 529. It's a little more than that. You don't really need to worry about that though, since it's so close. So 23, and then fill all the rest of the digits you don't need with 0. Or sorry, all the digits you need to continue replacing with 0, and you'll get 2,300 easily in range. 31, 51.5 minus 20.4. Oh, okay. There are multiple ways you can do this. The easiest one is to just subtract the whole numbers and subtract the decimals. So 51 minus 20 is 31. That's your whole number. And then 0.50 minus 0.24 is 0.26, which will be your decimal portion. If x plus y is 15, x minus y is 5, and x squared plus y squared is what? Okay. Well, you got to add these two equations together. You get 2x is equal to 20 because these y's cancel out. Then you get x is equal to 10. And then you replace x for that, and you'll get y is equal to 5. Then you just have 10 squared plus 5 squared is 125. Reciprocal of negative 6 and 2/3 is what? Well, the reciprocal means you need to put this into an improper fraction and then flip it. So negative 6 times 3 is 18, plus this 2 is 20. So this number is going to be equivalent to negative 20 over 3. So flip that around, you get negative 3 over 20. And if you scale that out to fit a decimal form, you get negative 15 over 100, or negative 0.15. 34, 51 plus 5 times 20 minus 24 divided by 7 has a remainder of what? You can take the remainder of any number, basically any time, unless it's an exponent. So 51 divided by 7 has a remainder of 2. This is still just 5. 20 divided by 7 has a remainder of 6, and this has a remainder of 3. So 2 plus 5 times 6, which is 30, divided by 7 has a remainder of 2. 2 plus 2. And then subtracting this 24 divided by 7, which has a remainder of 3. So 4 minus 3 is 1. This also shows another method to do it, replacing this 6 with negative 1. Because technically speaking, you can kind of imagine it as 6 is equal to 7 minus 1. The remainder when 7 divided by 7 is 0. So that's why that also works. 35, cube root of 13,824. Well, there are two digits, and make sure you realize this is not an approximation problem. So there are two groups, which means you need two digits. Because this is cube, you have to make groups of 3. Well, 2 power to 3 is the closest you're going to get to 13 while being under. So your first digit has to be 2, because this 13 is your top group. And then what ones place cubed will end with a 4? Well, the only one that, I believe it's the only one, yeah, it's literally the only number that does that, is also a 4. Because 4 powered to 3 is equal to 64, which ends with a 4. Or sorry, 64, which ends with a 4. So your number has to be 24. 36, 3,900 is 6, times 6 minus 36. Well, this, if you've seen any of the previous guides, you'll realize this is the equivalent of 3,900 times 6, which is going to be the equivalent of 4,000 minus 100, all times 6, distributing that out if you want to make the math a bit easier in your head. And you'll get 23,400. How many integers are greater than 12 and less than or equal to 72 that are divisible by 8? Well, 72 divided by 8 is 9, which means there are 9 numbers divisible less than or equal to 72 and greater than, 0. So then once you have that, the integer not included in this range is going to be the integer 8, which is obviously divisible by 8. So subtract that 1 from that 9 total, and you'll get 8 as your answer. 38, given all these split series, and then what is p plus q plus r? If you add up the first 3 terms in all these, you get 2 plus 3 plus 5 is equal to 10. 4 plus 6 plus 10 is equal to 20. 6 plus 9 plus 15 is equal to 30. So p plus q plus r has to be equal to 40. And that'll get you your answer. 39, find a digit b is greater than 0 such that 39b9 is equal to that giant thing over there. Well, the only square, all this is squared, and the only square that starts with 39 is 3969, which is equivalent to 63 squared. You may not know that, which is understandable, but hopefully you should realize that the value of 6 will get in b will get you 7 times 9, which is 63, which is very clearly close to what you're looking for. So yeah, b is equal to 6. Okay, 40, cube root of 515. Well, the cube root of 512 is 8, so it's basically 8. times square root of 515. Well, it's pretty close to square root of 529, which is 23 squared. So multiply by 23. And then since we kind of, why am I struggling to speak? Since we kind of rounded up for this 23, we're going to round down for this 515 and change it to 500. And once you have that, you have 8 times 23 times 500. If you don't want to do 8 times 23, that's perfectly understandable. You can just do 230 minus like 46 and just see it's close to like 190 times 500. And get in that range. If you did multiply it out like normal, you get 184, I believe. Yeah, you get 184 times 500, which I believe which should still be in range for this. Yeah, so 41, 2 over 45 is equal to what percent? Well, 2 over 45 is equal to 4 over 90, and now we have a trend that we're used to. So 4 over 90 is equivalent to 0.044444, because, this 4 is repeating, so you're dividing by 90, and and then 0, 4 minus 0 is 4. Then once you have that, you multiply this by 100, and you'll see that you get 4.4444, so 4 and 4 over 9. 42, 7 powered to 5 plus 3 powered to 5 minus 2 divided by 10 has a remainder of what? Well, since these are both being powered to odd numbers, the 7 and 3 cancel because they have the same distance from 10 to 0. Then once you have that, you just have 0 minus 2, which has the same remainder as 10 minus 2 is equal to 8, because 10 divided by 10 has a remainder of 0. 43, 2401 has how many positive integral divisors? 2401 you should recognize that as 49 squared, which is equivalent to 7 powered to 4. Well, you have all your primes and exponents, so now you would multiply all the exponents plus 1. Well, we only have one exponent here, so 4 plus 1 will get you 5 integral divisors. The arithmetic mean of the set of 5, 15, 24k is 16. Find k. Well, the mean is equivalent to the sum of all values divided by a constant 4, or not a constant, by the total number of terms, which is 4. So 5 plus 15 plus 24 plus k is equal to 64. And then you just subtract all this stuff from 64 and you'll get a value of 20. 45, if 3x plus y is equal to 5 and x minus 2y is equal to 5, then x is equal to what? In this case, you'll want to modify it so you can cancel out the y's when you add the equations. Multiply this equation by 2. 2x plus 2y is equal to 10. And now you can add the two equations and get 7x is equal to 15. Sorry, that was incorrectly marked. This should be a 7. Yeah, once you have that, you get your answer of 15 over 7. 46, 1, 2, 3 base 4 times 2 base 4. Well, the first thing you should realize is 2 base 4. We're looking for the answer in base 2. So that's equivalent to 1, 0 base 2. Because 2 powered to 1 times 1 is 2. So now that you have that, all this means is that since you're multiplying by it, you just add a 0 at the end of whatever 1, 2, 3 base 4 is in base 2. So there's your 0 here, and now we begin converting. How you can do that is, well, since this is base 4, which is a multiple of base 2, you can separate all these out. So 3 is equivalent to 1, 1, so write 1, 1 there. 2 is equivalent to 1, 0, write that there. And then 1 is equivalent to 0, 1. Obviously, you don't write the 0 at the front, and you'll just write 1 singular 1. And you get this nice answer right here. So 47, 2 factorial times 3 factorial times 5 factorial divided by 4 factorial times 6 factorial. I didn't write I swear I wrote the solution for that. Whatever. So maybe I guess I forgot. Kind of had to reprint everything after like my software lost the paper. I guess I was rushed. But in any case, how to solve this problem? We're going to assign you can imagine this as a numerator and this as a denominator. We're going to send our soldiers to battle to fight their equals. The 3 factorial is going to fight this 4 factorial right here. 3 factorial divided by 4 factorial, which is 1 times 3, 2 times 3 over 1 times 2 times 3 times 4. Clearly, that's just going to leave a divided by 4. Do the same thing for this 5 factorial divided by 6 factorial. By the same process, it's going to be equivalent to dividing by 6. So now you have 2 factorial over 4 over 6 is equal to 1 over 12. 2 dice are rolled. The probability that sum of the top faces is greater than 10 is what? Well, how dices work, there's one chance for it to be equivalent to 12. There are 2 possibilities where it's equivalent to 11, and so on. And there are 6 power to 2 is equal to 36 possibilities. Add the chance of it to sum to 11 and 12. You get 3 over 36 is equal to 1 over 12. And then convert that to a fraction. So 100 over 12, basically. 49, let R1 and R2 be the roots of this equation. Find R1 plus R2 minus R1 times R2. Well, R1 plus R2 isn't too hard. This basically represents the distance from the center that both of the roots are going to be found. So as a result, the sum of the roots is going to cancel out that part you're subtracting and adding to just leave yourself at the center times 2. So the center is clearly 3 over 2 for this x. So that multiplied by 2 is equal to 3. Now a bit harder to figure out is the roots multiplied by each other. Well, if you expand things out and all that, using uh, square roots and then changing the x and y squared, I won't go through the proof, you can do it yourself. But basically what you get, your answer is going to be this 3 squared minus this 5 here, divided by this 2 squared, which will get you a value of 1. Then once you do that, 3 minus 1 is equal to 2. I swear, why am I missing stuff? Hope Kami wasn't being weird. In any case, 50. This one isn't too hard to explain though. You have a lot of digits here. So let me see, you have 7, or we're going to use this 13 and this 5 basically. So after the 13 there are 6 digits, and after this 5 there are 2 digits. So what number multiplied by 5 will get you 13? Well, 26, of course. You're dividing by a little more than that though, so let's go to 5, or 2.55 instead of 2.6. And then once you have that, subtracting the 6 digits minus this 2 digits means you have to have 4 digits after the first 2. So 255 and then 2 zeros to counteract that. 51, 114 minus 7 and 1/2 minus 22.5. Well, if you add up these two numbers you're subtracting, you get negative 39.75, which is very close to minus 40. You just have to add a 0.25 to compensate. So 140 or 114 minus 40 plus 0.25, that's a lot easier to do, 74.25. 52, well, as you can see, it's identical to the previous one, but instead of subtracting 17.5, you're adding 17.5. Which means what you need to do is take the previous and add 17.5 times 2, because you went from because you have to counteract it, and then you have to add 17.5 more. 17.5 times 2 is equal to 35, so add 35 to your previous answer. 53, well, this is adding 0.25, this is unchanged, and this is adding 22 and removing the negative 22 and 0.25. So in other words, you're adding 44.25 plus 0.25, so You're adding 44.5 to the previous one. Do that, and you get 153.75. 54, 2 plus 7 plus 9 plus 16 plus 25 plus 41 plus 66, etc., etc. List of Fibonacci series with some unknown numbers. This m is going to be equivalent to 41 plus 66 is equal to 107. And this n is going to be equivalent to this m of 107 plus 173 is equal to 280. And then why am I swear I don't know why I'm writing stuff wrong. I'm sorry about that. This should be a 280. For some reason I just saw that as a 73, which doesn't make sense. 280. And then so you have to add 453 times 2 plus 280, then subtract 7. I swear I did the math and then I wrote it wrong, I guess. I didn't just look at the answer key. I mean, I did to check it, but you know. 55, if f of x is equal to 3x plus log base 4 of x, then f of 8 is what? Well, 3 times 8 is 24. Log base 4 of 8, 4 powered to 1.5 gets you 8, so add 1.5. And you get 25.5. 56, 4 and 1/5 said what percent more than 3 and 1/12, or 1/2? Well, convert these to improper fractions and then divide them to get the percent. So 4 times 5 plus 1 is equal to 21, 21 over 5, divided by 7 over 2. So you're dividing by fraction, flip it, and multiply, and you get 71 over 5 times 2 over 7. Move it around, you get 21 over 7 times 2 over 5, which is 120%, which is 20% more than 100%. And that'll be your answer. 57, this is just adding and subtracting in normal bases. In this case, you don't even have to do anything fancy. Just add up all the ones places and add up all these one places subtracted by this ones place. Do that for the tens place, the hundreds place, and the thousands place. And you'll get 1,122 in base, the equivalent in base 6. Doesn't really make sense to say 1,000 there, etc. Okay. 58. 48 plus 32 plus 21 and a third plus 14 and 2/9 is plus whatever is equivalent to what? Well, this is a geometric series. Each term is the previous one multiplied by 2 over 3. Then you have your formula for geometric series. The starting number divided by 1 minus the ratio of 2/3. 48 over 1 over thirds is 1 over 3 is equal to 48 times 3 is equal to 144. Okay, 59. This is the one that's hard to explain. So first off, we can take the remainder when 37 is divided by 23. You get 14. Well, into 14 power to 12 divided by 23. Well, since you're powering by an even number, that's going to be equivalent to the same thing, 23 minus 14 power to 12, which can be proven with, some cool algebra. Again, I'm not going to show you because I can't really do that in writing form very easily. Then you have 9 power to 12. And then once you have that, you can take the square root of that, and you get 3 power to 24. Square root of this, multiply the exponent by 2, 3 power to 24. And now you can use your exponent remainder theory. There are 22 relatively prime numbers to 23, since 23 is prime. So 3 power to 24 mod 22 is equal to 3 power to 2 is equal to 9. 60. 10 times pi power to 2 minus 1 squared. Well, pi squared is approximately 10. So 100 minus 1 is equal to 99. It's a little less than 99 because pi squared is a little less than 10. So just a little less than 100 squared, which would be 10,000. You get 9,500 to make sure you're in range. 61, you're looking for b plus c. Well, the C value is the upper part to the right. That means you take the first, uh, sorry, row here, multiply it by the second column here. So 2 times -6 plus 5 times 10 is equal to 38. Then this B is equivalent is on the second row and first column. So second row times first column. So 3 times 1 minus 7 times 3 is equal to -18. 38 minus 18 is equal to 20. 62, tangent of pi over 3. You should have that memorized to be square root of 3. Then tangent of 5 pi over 3. Well, that's just going to be the same thing, but on the other side of the unit circle. So it's just going to be negative square root of 3. Then you multiply those two together and you get -3 as your value. 63, 2.5 fathoms is how many inches? So 2.5 times 6 will get you, to convert to feet, will get you 15 feet. And then 15 feet times 12 inches is 180 inches. 64, 300 degrees is k pi radians, and what is k? Well, to convert from degrees to radians, you divide by 180 and multiply by pi. So 300 over 180 is equivalent to pi over 3. Or sorry, 5 over 3 multiplied by your pi, which is covered in the answer. 65.43 base 5 is what in base 10? Well, this is equivalent to 4 over 5 plus 3 over 25, which is equivalent to 20 over 25 plus 3 over 25, 23 over 25. Multiply that by 4 to convert it to a base 10 decimal, and you get 92 over 100, or 0.92. Which element is both a triangular and hexagonal number? Well, hexagonal numbers are basically you just got to run through it. Triangular numbers are very easy to see. They're equivalent to one number times the next number over 2. So 21 is 6 times 7 over 2, and 45 is 9 times 10 over 2. So that immediately eliminates 35. Then you have to figure out, is 21 a hexagonal number, or is 45 a hexagonal number? In my example, we went with 45. Try and find a number that would get you an answer close to it. In this case, the thing would be 5. You multiply that 5 by the hexagonal minus 2, so 6 minus 2 times 4. So 5 times 4. And then you subtract it by the type of number minus 4, which would be 6 minus 4 is equal to 2. So 20 minus 2 is equal to 18. I forgot to write divided by 2 again, my bad. Multiply that by 5 and you get 45. So yeah, just make sure to divide that by 2 again, because I guess I just suck at writing things. 67, log base 2 of 32 minus log base 5 of 25 is equal to log base 3 of x. Well, 2 power to 5 is 32, so log base 2 of 32 is 5. And 5 power to 2 is 25, so 5 minus 2 is equal to 3. And then 3, now that it's a log base 3, you have to take 3 power to your number of 3, and you get an x value of 27. 68, this is the equation for difference of cubes. So that it's equivalent to this cube minus that cube, because it's x minus y. So 5 power to 3 minus 15 power to 3. 5 power to 3 you should know is 125. And 15 power to 3 you should have memorized as 3375. So 125 minus 3375 will get you negative 3,250. 69, this number base 4, square root of that, and base 4 again. The easiest way to do this is just convert this to base 10 and then square root it. So 4 power to 0, 4 power to 1, 4 power to 2, 4 power to 3 times 1 gets you 64. Square root of 64 is 8, and then you convert it back to base 20 or base 4. 4 times 2 is equal to 8, which would be what this digit correlates to, and then you have nothing left over, so 2, 0. 74 plus 5 plus 6, etc., all the way to plus 13. This is another arithmetic series. Subtract the first and the last number, divide it by your ratio of 1. So 13 minus 4 divided by 1 is, 9. Then you add 1 to that, and you get the number of terms, so 10 terms. Then once you have that, you multiply the number of terms by the sum of the first and the last number divided by 2. So 10 times 17 over 2 went to 17 times 5, which is 85. And then you have your squares ending in 5 trick. So 8 times 9 is 72, and end in 25. 71, if f of x is equal to 5x over 6 plus 3 over 4, f inverse of x is ax plus b. A plus b is what? Well, if you're taking the inverse of that, that means you replace this with y, and this value right here with x. Now you have x minus 3 over 4, and then you have to change this, so multiply by 6, divide by 5. So what this all means is that you're going to be multiplying 6 over 5 by this 1, that would correspond to this a, minus the 3 over 4 that was shifted over. So 6 over 5 times 1 over 4. 6 over 5 over 4 is equal to 3 over 10. A very hard problem to do, I will tell you. Very impressive if you can get that on your own. 72, let f of x is equal to sine of 2x, find f double prime, f pi over 12. Well, f prime, you take the derivative of sine, you get you get cosine. Yeah, sorry. This is not a negative. I cannot type. I'm sorry. Yeah, this is not a negative. This is positive. This is positive 2 cosine of 2x, and you multiply by 2 because chain rule. You multiply by the derivative of 2x, which is 2. And then you take f double prime, and you get a negative 4 sine of 2x. So now that you have that, you get negative 4 sine of pi over 6, which is 1/2, and you get negative 2. 73, sum of the squares of diagonal of parallelogram with 2 side lengths. Well, it's just going to be equivalent to the Pythagorean theorem of your 2 sides multiplied by 2. Can't tell you exactly why that's the case, but it is. So 49 plus 121 is 170. Multiply that by 2 and you get 340. 34, h of x is equal to x plus 3 powered to 0.5. Where's the relative minimum? Well, the relative minimum happens when it's symmetric, so it's just when this value is equal to 0. So yeah, it's symmetric at x equals negative 3. 75, the double integrals. I'm not going to go over proving it to you, but basically what you do when you're given double integrals of x, y, you take the two bounds, you square it, and subtract them by each other, and then you divide by 2. So 4 squared minus 3 squared is equal to 7. Divided by 2 is 7 over 2. And you do the same thing for this. So 7 over 2 times 2 squared minus 1 squared. So 7 over 2 times 3 over 2 is equal to 21 over 4. So 6, the axis of symmetry of the graph of f of x is equal to 5x squared plus 15x minus 24 is what? Well, axis of symmetry of a quadratic equation, a negative b over 2a, negative 15 over 10. So negative 1.5. 77, given 1, 5, 1, 4, negative 3, 7, negative 10, 17. This is a pretty hard series to figure out on your own, but if you do figure it out, you'll see that it is f of n is equivalent to the term 2 before minus the term 1 before. So 4 is equal to 5 minus 1, negative 3 is equal to 1 minus 4, 7 is equal to 4 minus negative 3, and finally k is equal to negative 10 minus 17. 78, 402 power to 3. This is going to be your cubed with a 0 in the middle. So what you do is you take it in terms of digits. Your first two are going to be equivalent to the 1's cubed. So 4 power to 3 is 0.8. Then now you have your next two digits, which is going to be this power to 2 times that power to 1 times the number of ways that can happen, which is going to be 3 combination 1 or 3. So yeah, 2 powered to 2 is 4, times 4 is 16, times 3 is 48. Now that you're on the next step, this powered to 1 times that powered to 2 is times 3 combination 2, which is also 3, is equal to 96. And finally, 4 powered to 3, which is 64. Okay, 74, or sorry, 79. This is being multiplied by a bunch of 11s. You just do all the multiplying by 11 tricks. 6 times 1 plus is 6. 4 plus 6 is 10. 0, carry 1. 1 plus 4 plus 6 plus 1, 2, carry the 1. Do that for these 3, this 2, and that finally that 1. And you will get your answer of 3,124,206. 80. 73.75% of 51524 is what? Well, it's a good bit more than 0.9 times 500,000. So that's just because this percent is a lot higher than that, even though you're moving it down a good bit. That value would get you 4,500. So add a little more to that to get 4,700. If you want to be extra safe, you can just sorry. You should be able to realize that since estimation problems are judged in terms of 5%, if you use 0.9, you'll still get the answer in range. So you can write 4,500, or sorry, no, you can't necessarily because you rounded down. But if this was 50,000, you could just write that. And that's why we're adjusting it a bit. So yeah, 4,700, which should be in range. All right, I hope you enjoyed the guide. If you have any questions, leave a comment or ask me in person. I'll see you guys later.